Bismillahirrahmanirrahim. Hello, my dear students. How are you? I hope you are fine and enjoy good time and good health. Today, inshallah, we will soon talking about mathematics of finance with simple interest, chapter number 2, the present value. Let's start with the questions. We know that S equal B plus I and interest I equal B RT. So we can get S equal B times 1 plus RT. To get the present value, B equal S over 1 plus RT. Problem number 1. What investment now will provide the resource in 15 months to pay an $8,525 obligation if money is worth 6.5%? So we need to get the present value of the future value $8,525 for the total time 15 months with a rate of 6.5%. This is the timeline. The future value here equal $8,525. We need to get the present value now. The total time equal 15 months with 6.5%. By using the future value, by using the present value B equal S over 1 plus RT, S 8,525 over 1 plus 65 per thousand times 15 over 12. So B equal $7,884.39. Problem number 2. Pembroke Corporation intends to make 2 equal deposits on May 1, 2005 and July 15, 2005 to provide for a capital expenditure of $568,950 on October 18, 2005. Find the value of those deposits if money is worth $5.25. Let's draw the timeline. Here is X on May 1, 2005 and another X, the second payment, on July 15, 2005. Note that X represents the future value, the present value of 568.95 and 568.95 represent the future value of the two payments X, the first and second X. We need to get X on May 1 and X on July 15. We can use the formula of S equal B times 1 plus RT. At the beginning, we must calculate the time for the first payment and for the second payment. Note that the time for the first payment is the distance between May 1, 2005 to October 18, 2005. And the time for the second payment, X2, it's the distance between July 15 to October ET. For the first payment, we will start with October 18, for days 18, for months 10, and year 2005, minus May 1, 2005, day 1, month 5, and years 2005. We need to get the difference. 18 minus 1 equals 17, 10 minus 5 equals 5, and 0 years. To get the time in days, 5 months times 30 plus 17, so the time is equal 167 days. And for the second payment, we will start with October 18, 2005, for days 18, month 10, year 2005. July 15, 2005, so days equal 15, month equal 7, year equal 2005. We will subtract 18 minus 15 equals 3, 10 minus 7 equals 3, and 2005 minus 2005 equal to 0. To get the time for the second payment, 3 months, 3 times 30 plus 3 days, so the total time for the second payment equals 93 days. Now, by substituting in the amount formula, is equal B times 1 plus RT, and for the two payments, we have S equal B times 1 plus RT1 plus B times 1 plus RT2. I take B as a common factor, so S equal B times 1 plus RT1 plus 1 plus RT2. And to get B equal S over 1 plus RT1 plus 1 plus RT2. B represents the unknown payment X1 or X2. By substituting for S equal 568.95 and for a rate with 525 per 10,000, and for T1 167, and for T2 with 93, we can get B equal $279.18. Problem number 3. A borrower signed a note for $12,000 due in 6 months with interest at 13%. 2 months after the note is signed, the holder of the note sells it to a buyer who charges 15% simple interest for discounting. How much does the seller receive? This note is an interest-bearing note. The $12,000 here represent B, and we need to get the future value for this amount after 6 months with 13%. Then we will use the amount we calculated to get the present value before 4 months before the end. Look at this time diagram. We have $12,000. We need to get the future value after 6 months, then we need to get the present value before 4 months before the end, or 2 months after the start time. Note that we will use R equals 13% to get the amount, and we will use R equals 15% to get the present value. The answer: at the first, the maturity value. To get the maturity value, we use the amount formula, S equal B times 1 plus RT, by substituting for B equal $12,000 and for R equals 13% and for T equals 6 months. So S equal 12,780. Note that we use R equals 13. And to get the present value, by substituting in present value formula, B equal S over 1 plus RT, and by using the calculated amount for S, 12,780, and for T equal 4 months with 15%, so B equal $12,171.43. Problem number 4. A debtor signed a note for $22,500 due in 6 months with interest at 10%. 1 month after the debt is contracted, the holder of the note sells it to a third party who determines its value at 13% simple interest. How much is received for the note? So the debtor signed a note for $22,500, which will deserve after 6 months with 10%. So B here equal 22,500. We need to get S after 6 months. Then we need to get the present value before 5 months from the end, with a rate of 13%. We can show that from the time diagram. We will start with B, 22,500. After 6 months, we can get S with 10%. Before 5 months from the end, or after 1 month from the beginning, we need to get the present value with 13% as interest rate. The answer: at the first, maturity value. We can get the maturity value by using S equal B times 1 plus RT, for B equal 22,500, and for R 10% for 6 months. So S will be equal $23,825. And to get B equal S over 1 plus RT, for S 23,625 is here, the calculated amount, the future value after 6 months. And for 13% interest rate, the time here equal 5 months. We can calculate the 22,411. Problem number 5. On June 12, 2016, a borrower signed a note for $13,600 due on March 9, 2017, with interest at 9.5%. On October 20, 2016, the holder of the note sells it to a buyer who charges 10% simple interest for discounting. How much does the seller receive? So, at the first, we must draw the timeline. We will start with 13,600 on June 12, 2016, and we need to get the future value on March 9, 2017. After that, we will get the present value on October 20, 2016. Note that we use interest rate R equal 9.5% to get the amount, and we use the interest rate 10% to get the present value. At the first, we must calculate T for the amount and T2 for the present value. To get T, we will subtract March 9, 2017 minus June 12, 2016 for the first, or to get the amount. March 9, 2017, day 9, month 3, and 2017 as a year. June 12, day 12, June, month number 6, and the year 2016. We will start by subtract days. 9 minus 12 get a negative difference. So we will take 1 month from 3. The total days will be equal 39 minus 12, which is equal 27 days. We have 2 months. 2 months minus 6 equal negative 4. We haven't a negative months, so we will take a year from 2017 with 12 months. The total months will be equal 14 months. The total months will be equal 14 months. So to get the difference, 14 minus 6 equal 8. We have 8 months and 27 days. So the total time here equal 8 times 30 plus 27. The time is 267 days. And the time for the present value, it's a distance from October 20 to March 9. We will start with March 9, 2017, day 9, month 3, and year equal 2017. Minus October 20, 2016, so day equal 20, month number 10, and year 2016. We will start with days. 9 minus 20, we will get negative 11. We haven't days on negative, so we will take 1 month with 30 days from 3. We have 39 minus 20 to get 19 days. We have 2 months. 2 minus 10 equal minus 8. We haven't a negative months, so we need to get 1 year from 2017 with 12 months. The total months here equal 14 months. 14 minus 10 equal 4. The total time equal 4 months, 19 days. To get them in days, 4 times 30 plus 19, which is equal 139. The answer, we will start by calculating the maturity value. By using the formula S equal B times 1 plus RT. For B equals 13,600 and for interest rate 9.5% times 267 days over 360, so S will be equal $14,558.23. We need to use this S to get the present value. By using the present value formula, B equal S over 1 plus RT, and for S 14,558 with interest rate of 10% for a time of 139 days, we can get B equal $14,017.02. This is the last example. Thank you for watching. For any question, leave your comment at the bottom of the video and I'll try to answer it next time.